Okay, so
the recording starts. So today I'll have a brief introduction of structural equation modeling, and because we only have 1 hour and a half, and I just talk about really basic stuff. Actually, it can be a course, 4 credit, 2 credit course. But I just basically talk about some basic stuff. So I'll talk about why we use SEM and what is SEM. SEM stands for structural equation modeling. And also I'll talk about the steps to conduct SEM. And also next part is about how to run the SEM in R. I know some people already know how to run SEM in SPS as Amos, but it's a different way to run SEM in R. And I'll give a specific example. So SEM is a statistical framework for testing and estimating relationships among the variables. The variables can be observed variables. You directly measure the variable. And also there can be latent variables. So why we use SEM to run analysis instead of using regression? And first of all, SEM take account into the latent variables. Regression does not do that. And also, SEM allows multiple outcome variables. Regression only allows 1 variable as an outcome variable. But SEM there's more flexibility about the shape of the model. And what is a latent model? So these variables are not directly observed, but it is a hypothetical variable that is inferred by other observed variable in the model, in the structural equation modeling process. So for example, age and gender are obviously observed variables because you can just ask people what is your age, what is your gender. But most of the psychological constructs like self-efficacy or leadership or engagements or any kinds of psychological constructs, they are not directly observed. Instead, you actually use a scale that contains like 9 or 10 or 20 items to measure 1 variable. So those items are actually observed variables, and this construct is a latent variable that is inferred by multiple items. So if we want to consider the latent variable, instead of just averaging all the scores of all the atoms, we can use SEM to see the relationships between each item and the latent variable, and also the relationships between the latent variable and other observed or latent variables. So that's why we use SEM. So there are some main purpose of the structural equation modeling. The first is to test the theoretical model. So you want to have some kind of like empirical studies that you have a theoretical model that you want to test with the data. And you build a model, you want to test whether the model exists. You can use SEM. So it's very useful in theory building process. And if you only, in that model, if the outcome if there is only 1 outcome variable in the model, you can use regression for sure, but if there are more than 1 or you just want to use SEM, you can use it to test your model. And also the second purpose is to conform the structure of the skill. So last time we talked about conformatory factor analysis. We want to conform the structure of the skill. So we use SEM. So CF is a specific case of SEM. And the third, I found in the recent in the published papers that if they want to have a empirical study and they have a lot of measures covered in the research, they collect a lot of data and they use different measures to measure different constructs. And they will do a CFA to test that this measures, each of the measures is measuring different things. So this is done by specifying different factors in the model, compared models. So for example, there's one paper that uses 9 measures, and they threw all the measures in the CFA. And they specify a 9-factor model. And they specify all kinds of other models, like a 4-factor model, 1-factor model, 6-factor model. So it turns out that the 9-factor model is the best model. So that means that, okay, these measures actually measure different things. So it's a kind of discriminant validity, even though there's no skill validation process involved. So if you want to realize the first purpose, you better do the third thing at first. You show that these measures are actually measuring different concepts. So these are purpose of SEM, but maybe there are other purposes, and I do not know yet. But at least there are 3 purposes in there. There are different kinds of SEM, and CFA, the conformatory factor analysis, is one of them. One type of SEM. The simplest one is called a path analysis. So in that analysis, no latent variables involved. All the variables in the model are observable variables. So that's path analysis. And there's a CFA. CFA, there are latent variables involved in the model, but does not involve any causal relationships among the latent variables. So among the latent variables in the CFA analysis, there are only correlations. So for example, this scale has 3 dimensions, and each dimension is measured by 3 items. So the 3 dimensions are correlated with each other. There are no causal effects or causal relationships specified in the model. So that's conformatory factor analysis. And the third one is the full model. It's a kind of a combination of path analysis and also conformatory factor analysis. So it has everything. It has latent variables. Latent variables are covered, and so also in the model, the causal relationships are specified in the model. So this part is like path analysis, but latent variables are covered. That part is like CFA. Yeah.
Are they just theoretical differences, or do they actually differ in terms of how you?
It's not really.
So
In nature, they are the same thing.
Okay.
You just
Different
ask
boxes.
the machine to do different things.
Got it.
You have different scripts,
Got
so
it.
they do different things. So it's like CFA and path analysis are like a truncated version of the full model. So the full model is a real SEM. It's like you go to McDonald's, you order a meal. You do not want a drink, so you throw out the drink. There are only burger and fries. It's like CFA. And next time you order a meal, you do not want the burger, you throw out the burger. That's like path analysis.
Oh, that makes sense.
So, and third time you go to McDonald's and order a meal, and this time you want everything.
Got it.
It's like that.
The other term is, they call it the measurement model and the structural model, right?
Yeah.
The measurement model is the CFA, and then structural model is when you
Add the
make the
relationship.
relationship between the variables.
Yeah, so yeah, I'll talk about that later. These are major three types of SEM. Here's an example. Let's see. I just want to make sure the it's recording. Yeah, it's recording. So you can see the cube or rectangular. These are observed variables in the graph. So all the cubes are observed variables. You can see the arrows. These are causal relationships. So you can see in the past analysis there are causal relationships specified, and they're only observed variables. And also there's a CFA. That's the graph from last workshop. So you can see here these are hypothetical construct or latent variables, and they are informed by these items. And you can see the curves here, there are no arrows. So there are correlations only. And that's the full model. And you can see these are latent variables. And they have arrows from one bubble to another bubble. These are causal relationships. And also they are inferred by the observed variables. So that's a full model. There's a like part of CFE, part of like combination of past analysis and CFE.
Would you be able to talk to how measurement error is addressed in all three models?
Measurement error.
Yeah, how, you want to talk about the error, a variable in all, and how it's depicted in these three models? Because that's a distinction with SEM, right? You consider error at the item level, that's accounted for, but you don't get that when you use a composite variable in the traditional regression analysis.
Oh yeah, I forgot that part, sorry.
Oh, like for example, in the first, when you look at the path diagram, you depicted the error variable, right? In the first one. So that, but you have it only for the composite, right? And then, but the difference when you go to the
Yeah, that's
structure-
an error term.
Yeah, but you don't get that at the item level. So one of the benefits, the strengths of SEM is you have the error term at the item level
Okay.
with SEM, but you lose that when you do a regression analysis where you're only having the error term for the composite measure.
For the outcome.
No, basically you aggregate like maybe self-efficacy scale.
Oh, okay.
Right, you have 5 items, but the error term for all 5 items is not accounted for at the item level with a path analysis or you know, whether you're using process or a traditional regression model. But with SEM you have to.
Yeah, so every item is considered in the model. So if we do a regression, we must use a composite score. So, but if you average all the items, error terms are lost, right? Okay. So that's at least another advantage of SEM. Okay. Okay. But in this graph, error terms are not there, but there should be there, but it's not. They are not drawn on this graph. Okay, so there are different kinds of variables. There are exogenous variable, and there's an endogenous variable. So the exogenous variable is a variable that causes change of other variables, and also is independent of other variables in the model. So simply these three are exogenous variables. So because they are not caused by any other variables in this model. So they are causing other variables because the arrows start from them, and this arrow pointed at other variables. So it means that they are causing other variables. So these are exogenous variables. And also there's endogenous variables. All these 4 are endogenous variables, because there are arrows pointed at them. So they are caused by other variables, or their change are dependent of other variables. it's like independent variable and a dependent variable in the ANOVA, but they use different terms. And ovals or the circles, bubbles, they are latent variables. And rectangles and or cubes are observed variables. So there are different arrows. The direction arrow, like this, they specify the causal relationship. So there are non-direction arrow, like here. These are correlations. So they just correlated. There's no direction of the relationship. And also there's bidirectional arrows. So that is really rarely seen. But means that the relationship is the variables causing each other. So the bidirectional causal relationship. So that's components in the model. And next, yeah, the steps to do SEM is the same with are the same with the steps in CFA. So first one, specify the model. So tell the machine, tell the software what the model is like. You need to specify the relationships among variables. And also, the next step is to estimate the parameters, like estimate the model fit indices. Model fit indices can tell us how well the data fit model. So it's like you make a shoe, and you put the feet in the shoe, right? So the data is like a foot, and the shoe that's a model that you make. You wanted the foot fit the shoe. You want the data fit the model. And estimate parameters like coefficients. Like this, on each arrow there should be a coefficient, and in the model they are estimated. So next step is just run the analysis, estimate the parameters, let the software does the job. And the third part is you can make different models, and you compare the models to see which one is better, which one data fit which model better. And also last step is model interpretation, how they communicate and interpret the results with yourself and other people. And here's some best practice to run the full model, recommended by Mueller and Hancock. So they recommended a two-step strategy. So first step is to build a measurement model. It's actually a CFE. So all the hypothetical constructs are thrown in the model, and you do a CFE to see whether whether the items measure the hypothetical constructs or not. So you want to make sure that's the case at first. Then you examine the relationships among the hypothetical construct, which is in the structural model. So you can't do those two things at the same time, but it's not it's difficult to interpret. So you better do measurement model first. You make sure the measurement is right, and then you do the structural model to make sure that the relationships are right. That's for the full model. But for the path analysis, you don't have to do that because there's no hypothetical construct in path analysis. So for CFA, there's the measurement model is a CFA. Yeah. And stats software is just the same with last time. You can use SPI and AMOS. Advantages are easy to draw the model. You don't have to type. You do have to run the scripts, and you just click and use shapes to draw the model in the software. And the disadvantage is you need to install AMOS package, and also SPS is expensive, and also AMOS is not free, right? You need to pay extra for AMOS. Yeah. And you can use R. It's a free software. That's a advantage. And also, it's continual updating. It's an open source software. Anyone can contribute to this. It's like an environment. Everyone can contribute to it. And also, easy to use. You have experience in programming. Yeah, the disadvantages is you need to learn R language. Requires a programming skills. If you have no programming skills experiences, or it's hard for you to really code to program. And you can use iPlus. That's the most powerful software, most professional software to run analysis like this. And it solves more advanced problems. But requires programming skills. It's harder to use, I think. And also, it's a paid software. You didn't pay for the iPlus.
So currently, does OWL have the capability to do multi-level SDM?
Yeah, R has that ability too.
2-level, right?
2-level, yeah.
Okay. But not 3. Not that I want to do that.
I don't know.
Okay, okay.
I don't know if you can do it in R, but
I'm not sure.
Yeah, I know, yeah, for sure SC, M plus
M+,
does.
yeah.
Yeah, I'm interested in that question too. Do we need to download a different package, SEM package, with R to do multi-level, or is it within the current ones that use it as well?
in the current one,
Um,
yeah, in the Laban. So there are 2 or 3 or more packages that do SEM, but I'll use Laban
Yeah,
because that's what Andrew used.
yeah, that's fine.
Yeah, and Laban also is continue updating.
Right.
So some other packages they stop updating. So
Okay.
yeah, so the multi-level SEM in the Laban package, that's the new feature actually. So when I use
Ah.
Laban in that class,
Yeah,
they don't have that,
right.
but they update the package. But for M plus, it's more power. So
Yeah.
there's more flexibility. So we can run SEM in R. We use an example data set. So you need to install multiple packages into R, and R itself contains some packages, the default setting, but a lot of packages extend the function of R, such as Laban. So Laban package you can download from there. There are some resources that you can use. So these are steps to run the full model. Actually, the same steps with last time, CFA. Let's see.
Oh. You want us to follow with you on the computer?
Yeah, if you want. First, you have R installed, R Studio installed.
Mhm.
So R is the software itself, and is there a way to zoom this?
Shift plus or Control plus? I think.
Shift plus.
Go up to view on top. Zoom in. Oh, so it's control equals actually to zoom in. There you go.
Interesting. Yeah. R is a software itself. R Studio is the user interface built on R software. And you need to install the package Laban, and also you need to install the package Psych. You load the package Laban and Psych. And the next step is to import the data set So there is a existing data set in the Lavin package.
Oh.
So Lavin package not only include the functions, also include some data sets. So I just run this. So the data set is called political democracy. The third step is to specify the model. So in SPSS, you just draw the model. So that's where you specify it. But in R, you need really a program. So here you can see that's how you specify the relationship between observed variables and latent variables. That's a hypothetical construct, latent construct. And these are items. And this sign means that these items are under this latent variable. And also, this double tilde means that's correlation.
Okay.
Latent variable 1 correlated with latent variable 2.
So what's the equal and then the
Tilde.
sign?
That tells the machine that this latent variable is specified by this observed variable.
How do you identify what the marker variable is?
Marker variable.
Like for each latent construct, one of the items becomes the marker variable.
Oh, so the default setting is the first one, fourth item.
Okay.
And you can also specify by writing like this, one times. Yeah.
So if I want like O2 to be the marker variable, I just put 1 times O02.
Yeah.
So then it changes, the marker variable becomes 02 and not 01.
Yeah.
What's a
Yeah.
marker variable?
It's like when you get the latent variable, it's not a real variable, right?
Mhm.
So how do you estimate the score for each participant for that latent variable? Is like you specify one observed variable as 1. So like this. So if there is, that's the hypothetical construct.
Mm-hmm.
And these are observed variables, items. They have scores for each participant, right?
Right.
So, but this doesn't have, because this is hypothetical. It's a theoretical concept. So you specify, oh, this relationship is 1. The coefficient here is 1. So if this, so this construct has the score for each participant.
Mm-hmm.
And you use this to estimate other relationship like this,
Oh, got
can be
it.
like this, can be like this, yeah, can be like this.
Okay.
And later you standardize these coefficients. Because coefficients ranges from 0 to 1.
Right.
And this 1 is actually above 1 because you force the machine to specify this relationship to be 1.
Mm.
So actually you standardize them and they have other coefficients like this one is like this one is like this.
So if all your items are using the same scale, then it's pretty arbitrary which becomes the marker variable.
Okay.
Yeah.
So it's like, okay, yeah.
So usually any
Dummy
of
code
your
very
items can be a
much.
marker variable if they're all using the same scale.
That
Yeah.
makes sense.
So the default setting in the environment package is first item is the marker. But you can specify other observed variables as marker variable.
Got it.
And it usually doesn't really matter, does it?
Doesn't really matter.
Yeah. Unless it's the item that gets eventually dropped, like it has a weak factor
Right.
loading and back, so. Yeah.
Got it.
Yeah, yeah.
Thank you.
And also, that's how you specify the causal relationship here. This single tilde, and this is a endogenous variable, order dependent variable, and x1 and x2 are exogenous, exogenous, or independent variables. It's really similar to regression.
Makes sense.
And yeah, and so we want to do the full model. So let's draw the model here. So we have no eraser.
Oh, it's there, the back. Oh, right here.
So in the example data set, there are 3 hypothetical or latent variables. So it's like this. There's independent variable, outcome variable, and there's a mediate here. It's like this. And they are informed by multiple observed variables. The shape of the model is like this. So if we want to test this model, we do the measurement model first, which is just a CFE of the 3 latent variables. So that's how you specify the model. So these are scripts, and you write these scripts into this. And you can see here, there's 3 observed latent variables, int 60, dam 60, and dam 65. And you can see these are items, and also these are correlations among the items. So actually, these are from the example. There's an example online. They specify the correlations like this. They think that Y1 is correlated with Y5 and Y2 is correlated with Y4 and Y6.
Is that what that would mean?
They're correlating the items or the error term in the items?
The items. Yeah. Yeah, so that should be items. Yeah.
So like Y1 is part of dem 60, and they correlate Y1 with Y5, which is part of a different data construct.
Yeah, so
Yeah, how do you depict that in the, yeah.
that's the question. I don't know.
But that's not typical. Typically, you don't correlate items.
Yeah, typically don't correlate items with each other. Next step is to estimate the model. So we use the function CFA. It's a function here, and the model is a measurement model. The data is a depth, and if you run CFA, the result is saved in this thing called the feed measurement, and you can get the output. These are.
How do you specify? Feel free to tackle this question later, but I'm interested in how you specify the mediation in the mediated path in.
It's not really mediation. They don't test the mediation. It's just the model.
So here you don't test for like the indirect effect of your.
I think they have the new feature in the Win package to test the mediation effect.
Oh.
But in this case, that's the simplest case. There's no mediation effect tested. So they don't test they just test this model. You just have a CFA on the three leading variables.
Yeah, so I guess like you have to do it again with something like process or something.
Yeah.
So
You can do it
you
with,
can't do the direct effect like what like Amos can do with like Bootstrap. You can look at the direct effect.
Not that I know.
it's not covered in this workshop. I can look at it.
But it's new, right? You
It's-
said
it's
so-
new.
Yeah, that makes sense.
So you can
Okay,
just
so they
do
have
the,
that capability.
yeah, most basic things, just like set up three models. One model is from the independent variable to mediator. The second one is from mediator to, from the independent variable to dependent variable. And the third model is to add the mediator in the second model.
Oh, so it's
So there's
different
three
than-
steps, so.
You can't specify in one model and then.
I think you can with Latin package right now, but I don't use that.
Oh, is it
I don't have.
this- Is it this one?
Yeah,
You specify the direct effects, you specify the mediator, you specify indirect and also total
Oh.
effect. Is this Levon still?
Latin package.
Yeah, it's SEM, right?
Yeah,
That's the command.
yeah. So I think that's a new feature. I need to look at that and then learn
Yeah,
how to use that.
Just good to know that.
Yeah, but right now here it's just a CFA.
Okay.
Actually, I think I did that.
Let me see. And also, all in the output, it shows some information. All this
Is this the standardized output or did you have to request for additional?
standardized. Yeah,
This is standardized.
these are the information about the model. You can see degree of freedom, 31. This is the chi-square. Model fit test, that's chi-square, 38, degree of freedom of chi-square.
So RIMC is there.
Yeah, CFI, TLI, you can see it's too high, it's here, because that's example data set, right?
Right.
So it's almost perfect. And AIC, BIC, AIC, BIC, and Ramsey, SRMR, very good model.
So David, sorry to interrupt, just a quick correction. The question that Jeff asked about that too squiggly thing earlier, that is correlating the residual.
That's called residual.
Okay,
Yeah.
okay. So they have
Okay.
correlated residuals, okay,
Yeah.
which is generally not an recommended practice.
It's usually like after MI.
Yeah.
Yeah.
So these are correlated residuals,
Yes,
not correlated items.
correct.
Yeah.
Okay, so the double tilde means the residuals are correlated.
Mm-hmm.
What does it mean to, oh, so then what, the second line, Y2, Y4 plus Y6, so in one line they say that the residual for Y2 is correlated with.
With both of them, I guess.
Most of them, maybe. I didn't figure this out. I didn't know. I'm not sure yet.
Yeah.
I just copied this from the example.
It points to both with Y4.
Oh, they have that.
Yeah,
Okay.
I think it must be on one of David's slide or website. I can put it on the slide too.
Yeah.
Minor thing.
I don't know why they correlate like that, but just for demonstration.
Right.
Yeah. And here are some specific estimates, estimates of parameters. You can see here, in this column, these are the initial estimates of the parameter coefficients. You can see all the marker variables has one
Right.
coefficient.
Right.
And the last column is the standardized. It's called STD all, it's standardized. And the z value and the standard error and the p-value.
What is the second to the last one? Cause it took me
This-
forever to figure out which one is the one to report.
This one?
Yeah.
I don't know what
And
this
I
is.
couldn't find anything, and then I see, okay, the all one, fine. But-
And this one is a standard, this column is standardized.
Right, that's the
coefficients.
one that you report, yeah?
Yeah,
Okay,
and these are initial. You can see all these are one.
right.
Right.
All these are marker variables. You can see the marker variables don't have standard error, don't have z-value.
Second and last, is that the deviations, the standard deviations or?
It's
No.
standardized something,
No.
I don't know. And the covariances. And the variances for each item and latent variable. Yeah.
Can you request for modification indices from this output?
Yeah.
Is it just?
Can I talk about later?
Oh, later, yeah, sure, yeah, feel free, I'm just, so questions that come up, yes, say it.
Yeah, so, next step, let me see. That's the CFE output, and also, we can have the structural model. And, that's the structural model. Huh?
No, that's fine, you
Oh,
have
yeah,
it.
yeah, yeah. I think in this step, R is simpler than Amos. Because you just type
It's fast.
the relation, yeah, it's faster, and with Amos, you must click, and click, use arrows and bubbles. And you can see in here, these are measurement part, latent variables are specified, and these are the relationships. It's like this, so, yeah, so the DAM6 is the mediator. That's DAM60, and that's the independent variable is int60, and there is a DAM65. It's like this. So first row, int6 is regressed on DAM60. So is this relationship here. And in the second row, DAM65 is, yes, DAM60 and int6 are regressed on DAM65. So two rows to specify the relationships among three constructs. And also the correlations or error terms are here. And
So what you get from the output is you still get just the direct effects, you won't be able to request for the indirect effect from, because there's the path from int60 to
Yeah.
DAM65.
so to do mediation in Lagrange, you need to specify in another way. We have this feature right now in Lagrange.
Yeah.
But this one is just a simple SEM. Yeah. And we can summarize. I think it's the same. The model fit indices are the same. Actually, because you don't change anything instead of the causal relationships among hypothetical constructs. And you can have some extra steps. You can draw the model. You need to use this package called samplot. It's not in Lagrange, so it's not Lagrange is not a perfect enough. You can draw the model with this.
Are you able to run that to show what it looks like?
Yeah, sure. I'm writing. So we want to show the structure model. So it will show up in this part. So I make it larger, so you can see.
wow.
Yeah. So dam 60, Indy 60, and dam 65, the relationship here is pretty high.
Yeah.
It even shows the thickness of the arrow shows the strength of the relationship.
That's pretty cool.
Yeah. Oh, that's the mediator here. It's because the relationship is from here to here, and yeah, to here. That's a direct effect.
Huh. Interesting.
Yeah, and I think the words are too big.
You think, yeah.
Yeah.
But that can be easily changed.
Can be changed. So
Right.
you can. I just direct write something here. That's let me see, make it smaller. Yeah, that's better.
Mhm.
That's better. Make words smaller. But still like, because it's not a, in R the graph is really sloppy. If you want to report on the paper, you need to draw the plot by yourself. Yeah, it's not like Amos. So that's drawing. You can also compare models. If you think the model is not perfect enough, you can draw other model, specify other models. So I just randomly do this. I just randomly specify a model. And the relationships here are kind of a change, liquid, and do the analysis, summarize, and can compare the model, use the ANOVA function. It's not a real ANOVA. It's called an ANOVA, but it's not a, it's just a
Yeah,
model comparison, compare the chi-square.
Yeah, yeah.
And you can see the difference is really small. Yeah,
Yeah.
actually the second model is better.
Parsimony is king.
Oh, I know why. I deleted one item from here.
So as long as you have the exact same items, then you can compare, is that correct? Right, that is correct.
Yeah.
Okay,
You have to have
right,
the
right.
same
So you can
items.
have different length factors. Yeah.
Oh, so what I did is not right?
Yeah.
You
So
cannot really
you have
compare
to
the
have-
two models
Yeah.
with chi-square.
Yeah.
Because they have different degree of freedom. Yeah. No, it was different sets of observed variables. But we can compare the AIC and DIC. AIC and DIC.
Oh.
Yeah.
If you have, if you drop an item, you can use the AIC and the
Yeah.
Yeah.
Oh.
Yeah. And
AIC and
also,
what's
Bye, thanks, David. This was really informative, and I'm kind of excited now to look to LCM, hopefully.
yes, just
Ready?
stay for a second. There's one more feature
Okay,
we never
for sure.
seen. It's called
If you have to
modification
run.
indices
Yeah.
here.
Okay.
That tells you how you can modify your model. So here, these are the relationship that they recommend you to use
Okay.
in the model. So MI means how strongly they recommend you to use that relationship. You can use that here. Y1 is part of indices. This means that this variable is specified by Y1.
Wow.
But in the current model it's not. But they recommend to use that. You can see there's 2.20. You can use it here, 4.7 is really high.
Okay.
So if you use that part in the model fit will be higher. The data will fit the model better.
Yeah, the shoe will fit better. Got it.
Yeah, but
I like that analogy. It's really good.
yeah,
Fun.
but it's just based on the analysis itself, not based on theory. Because
Right,
the machine
right.
does not know theory. You need to think about it. whether it's theoretically so. Because if that's not consistent with the theory, there's no reason to specify like that. You
Right.
just- yeah.
You just take it out.
Yeah. If you think that some of them like some of these are really high MI, you can think, oh, whether that's the case,
Mhm.
it is a balance.
That's interesting.
Yeah.
Maybe can we ask just one additional thing?
Yeah.
Or maybe also Deanne, if you know this. Are you familiar with doing moderation with Laverne or?
What do you mean?
Because,
moderation, you
yeah,
need to
just-
create a product term.
We need to learn how to do that with, if you're able to do that.
I'm not able to do that because it's, if you concern the latent variable, right?
Yeah.
How to create a product for the latent variable.
Have you done that with?
Yeah, you have to, actually, let me take a look at my thesis. But to answer your question, yeah, Lafont actually do multi-level SEM now.
Okay.
So you get to do 2 level.
Okay, good.
And then for your mediation, it's also on here. There's a sample, so.
How about moderation then?
Moderation, okay, let me check. I don't see any moderation on here. Let me see what I did for my thesis. Yeah, I have to create interaction term prior.
Okay. Oh, not in the R studio.
You can in R, you
Okay.
can create new terms in R. I'm
Okay.
sure. I just did it in SPSS, it's so
Okay.
much faster.
Okay.
Yeah.
Oh, it's.
So create interaction term in your own data set and then run
Yeah.
that.
Yeah.
Okay.
X1, X1, M1, X. You can see here. There's a website
Yeah.
online, created by David Kenny.
Yeah.
I think that it's a really famous scholar about moderation,
Okay, great.
different cases,
Thanks.
and you can see here they need to create a product term
Okay.
to specify the moderation. But
Yeah.
if there are, it's about latent variables, how to do that. You can see here. If X has 2 items, M has 2 items. So how to create that latent variable? How to create this?
Yeah.
This is also latent variable by specifying like x1 times m1,
Okay.
x1 times m2, x2 times m1, x2 times m2. So each of the items in X is timed with each of the items in M.
Got it. Yeah.
So if there are more items, you create more product terms.
Yeah, that's why I use process for
Okay,
moderation.
yeah.
Any moderated mediation process is better.
Yeah. But for the process, the outcome variable must be just one variable.
Yes, yes.
Yeah.
If there are multiple variables, outcome variables, you need to like take part the
You
model.
have to run separate
Yeah.
analysis, yeah.
Yeah, from separate analysis.
Yeah.
You cannot really put them together.
Yeah.
Moderation, if you do this way, you can like put all the things together. Just create the
Yeah.
product terms.
Yeah,
Yeah.
awesome. Thank you, David.
You're welcome.
Your
This is really-
analogies are really helpful when you're teaching this.
Yeah.
Yeah, that really.
You're good, you did
Yeah,
stats.
very clear, it's very clear.
Thank you. And also there
Very
are.
systematic too, that's good.
There are other like stuff like.
Oh, wow.
Do you have you know this?
Oh, how to calculate sample size for
Yeah.
SEM?
There's actually no simple way to calculate.
Yeah, I
the
always
sample.
use rule of thumb, so.
Yeah,
Yeah,
rule of thumb.
so you always
Ten
use
days per
200.
Yeah, and then there's one paper that uses Monte Carlo simulation
Yeah.
Right,
to calculate the power.
is that
Yeah.
good?
Depends, all depends. So they list the 3 graphs here. So for example, if you do the CFA, average loading is 0.5. The loading of the item is
Okay.
average loading is 0.5. And if there's one factor, and there's 3 or 4 indicators for one factor. You only need less than 200 per space.
So for your average loading of 0.50, is that like a estimate or like?
If you, in your CFA, your average loading is 0.5 or above. So the thing is, if the average loading is higher, you
Yeah,
need
but where
less
does this average loading come from? I'm sorry.
average loading.
But this is after you already run the analysis? Like where does that loading come from? I'm sorry.
Yeah, after you run analysis.
Oh,
So
so
you-
that's not a priority.
So if it's in
No.
priority, if you guess, the average loading will be 0.5
Yeah, so
or
it's
more.
a S, okay.
You think the average loading will be more than 0.5. Right?
So most of us would be looking at model B. In most cases, the 0.65 seems about right. Your
This
loadings
Okay,
are
so you
about
still have to
0.6,
draw
0.7.
from some existing literature or something
Yeah,
like
what
that.
do you
to
expect
predict
the
that, right?
factor?
Okay, got it.
Yeah, so it shows that if average loading are higher, you need a smaller sample
Right,
to reach the same level of power.
yeah.
And if you use more indicators for one single factor, you need a smaller sample size. You can say the highest one is only use 3 or 4 indicators. You need a really high sample size.
Does this article go beyond 3 factors though? Because most of our models are like 5, 4 or 5, more than 3 factors.
I don't know. Does not. It's just these are just a simulation.
I
Just
mean,
a
but it's not,
illusion.
it seems very useful.
Yeah,
But
so-
if they modeled that beyond 3 factors, it would be.
Yeah, if you can replicate their Monte Carlo simulation, you can calculate the sample size. But I do not know how to do it.
Right, do you know what software does that? Can you do that in R?
M plus.
Oh.
R, I don't know, maybe.
Maybe.
It must be another package.
Okay,
Monte Carlo package.
what about path analysis? How do you estimate the sample size for that?
That's a good question. I don't know.
Okay, maybe it's the same.
Maybe it's not safe. I have no idea.
I mean,
So
this is FEM and path analysis.
But
is
path
technically-
analysis is basically like you're running, basically path analysis on an SEM software is like you're running process or.
Exactly, you
regression,
don't have
right?
any link in there,
Yeah,
right?
so the question is why do path analysis on SEM? You're not utilizing the benefit of SEM with kind of working with latent variables.
Well, it allows more, like, you can have more variables, because you cannot do that in process.
Oh, right, so you can have 2 dependent variables.
Yeah,
with-
exactly,
Okay.
exactly.
Yeah.
The other thing to note is, I mean, if you're concerned with sample, one practice is parceling. Have you heard the term?
Yes.
So parceling is, instead of like 6 indicators for one latent variable, you can have 2 indicators. And parceling, what it does is basically just combines maybe 3 of your indicators to become 1. So then you,
Oh, so then you have more power.
yeah. So you,
Mhm.
You have less items
yeah.
in analysis. have
In
more
that
power.
analysis, in that model, yeah.
Yeah.
Right, right,
And
right.
if you look at a lot of org papers, those with moderate samples, like you'll see a lot of parceling happening.
Yes.
Because they just don't have the power to,
Got it.
the sample size.
Yeah, so if there are too many variables in the CFA. So
Yeah,
there's a
parceling
paper.
happens after the CFA. So once you have your CFA,
Mhm.
you can actually combine
That's actually
indicators.
support that parcel.
There's a paper called a parcel or not parcel. It talks about the parceling. Yeah, this paper. So you,
Yeah.
yeah.
Oh, okay, great. What journal
What journals is called a structural equation model.
is that? Oh. All right. Awesome. Thank you so much.
Thanks,
Jeff.
David.
And
Maybe I
thanks,
have a
Jeff.
for, yeah, it was, this is really helpful.
Yeah.
David,
Can I have it?
Yeah, I'm up there. There's a meeting right now, actually, one of our alums who's working at Disney is presenting this at Structrual.
Oh, that one.
Yeah, she's talking about diversity initiatives at Disney.
Oh,
So
right
yeah,
now?
she said-
Disney.
Yeah,
What room?
Huh?
What room?
just here, the auditorium.
Okay.
So, yeah.
So that's why people are missing?
No, that's at 5 o'clock, but I think because we made lab meetings optional, people tend to, if they have other things going on.